In our previous video, we learned that we see objects around us because of the light reflecting from them. Some objects like sun, burning candle and the fluorescent bulb emitting light of their own. They are called luminous objects. Many objects around us are non-luminous. That is, they cannot generate their own light. However, these objects reflect the light from the luminous object from their surfaces. And because of this reflection, we can see such objects. In which direction do the luminous object emit light? They emit light in all the possible directions. Consider a fluorescent bulb which is glowing. It is emitting light in all the directions. Let us denote each direction with a straight line and an arrow on it pointing in the direction. When the light is traveling, so all these arrows present in various paths along which light is traveling. These arrows what we call rays of light. Here how we define ray of light. A ray of light is a straight line path along which light travels. So now we know that the light emitted by luminous object travel in a variety of directions. Suppose rays of light from these fluorescent bulb falls on the surface, it being non-luminous, reflect these rays and these reflected rays travel along the certain path. Consider this plane surface. Suppose one of the ray from the bulb strikes at this point. This is called an incident ray. We know that this surface will reflect this ray. And reflected ray will travel in this direction. Why only in this direction? Why not here or here? This is because rays of light obeys certain laws of reflection when they strike any surface. Draw a perpendicular to the surface at the point of incidence. This line is called normal. Here are the two laws of reflection. Any light rays obeys. To understand the first one, we first need to know what angle of incidence and angle of reflection are. The angle of incidence is the angle made by the incident ray with normal. It is denoted by I. The angle of reflection is the angle made by the reflected ray with normal. It is denoted by R. So our first law says that the angle of incidence is always equals to the angle of reflection. I equals to R. Here as I equals to R, if the incident ray strike this point, then the reflected ray will travel along this direction only. So as to keep the measure of the R same as I. If I move the incident ray here, then the reflected ray will also move to keep the measure of R same as I. I is always equals to R. Okay, this was about the first statement. What about the second statement? The second one tells us that the incident ray, reflected ray and normal all lie in the same plane. So if I draw the scenario on the piece of paper, I will get this. Incident ray, reflected ray and the normal, all three are in the plane of paper. The second law tells us they always be on the same plane. For example, if the reflected ray is in this direction instead of this, then the diagram will look like this. The incident ray and the normal are in the plane of paper, whereas the reflected ray is not in this plane. This violates our second law, and hence this ray will not be reflected in that direction. This is just not possible. It can only be like this. I will be equals to R, and they will lie on the same plane. I hope both the laws are clear now. In the next video, we will see an experiment based on this concept, which you can easily perform at home. Thank you. Thanks for watching the video.